Hi, my name is Liz, and I'll be presenting EZFluence, Radformation's Auto 3D Planning tool. EZFluence is an Eclipse plugin which is directly integrated into the treatment planning system. Through the API, data is automatically exported, so there is no need to manually export data or leave Eclipse. By using scripts in Eclipse, users experience a more efficient workflow through a single platform. EZFluence automates all 3D planning with any beam arrangement. EZFluence generates field-and-field and ecomp plans in seconds. Wedges and manual field-and-field segments can now be replaced with this tool. From breast to whole brain, single and mixed energies, EZFluence can even handle 3 and 4 field breast cases. In addition, EZFluence has added features like being able to convert an IMRT plan into a 3D plan to help with insurance justifications. Halcyon clinics especially find this helpful when moving to ecomp planning with a flattening filter-free beam. While field and field is a more intuitive way to plan, it isn't practical for the Halcyon 6 FFF energy. EZFluence removes a learning curve and standardizes planning among all users. There have been studies on EZFluence comparing automated breast plans to standard manual planning. Stony Brook, UCSD, and the University of Zurich all found significant time savings while improving plan quality by using EZFluence. If we take a closer look at UCSD's study, they compared manual planning of patients with both on and off protocol to EZFluence's automated planning. The study found that EZFluence was able to increase target coverage while decreasing V105 and also decreasing the total MUs. Let's review a few clinical examples together. So here I have a breast case with 2 tangents, and when you're running EZFluence, you'll need a few things to get started. The first thing will be 2 fields, and you'll still set those up just like you normally would. You can also add in blocks as needed. So here's an example where we have blocks already set up for this case, and then you calculate the open dose. Once the open dose is calculated, then we'll go to Tools and EZFluence. EZFluence starts to calculate and runs right on top of Eclipse. It's doing a few different things in the background. First, it's going to create a PTV eval structure. This contour is automatically contoured and it is a geometric structure. Our default definition is 5 millimeters from the skin, 5 millimeters from your field edge, and 5 millimeters from the OARs. The reason that we have automatically contoured this is to make sure you have a structure that we can analyze on the DVH. If you have your own in-house PTV structure, you can use that instead. From there, EZFluence will show us different plan options for this structure and this patient. Here we can see the pink line, which represents the plan on the CT. We can scroll through the CT slices, and we can see the coverage for this structure. If we'd like to evaluate a different plan, we have a slider bar, and we can use this to go in between the different plan options. We can see the coverage varying quite a bit from plan to plan, but all of these plans have one thing in common, and that is their max dose. And we can see they all have the same max dose of 105, and that's because this was set at the top here as a default. You can choose one of the 2 options when planning in EZFluence. If you prefer to have coverage set as a constant, you can use that instead. And then all of the different plan options will have the same coverage, and then we can see differences in the max dose and also the dose going to the breast. From here, our ecomp plan is complete. So once you choose your favorite plan on the DVH, then if we look at the beam's eye view, you'll see the fluence has automatically been generated. The blocks have been preserved. We also see fluence assigned to the flash region, and this is a very homogeneous distribution. We find that clinics, when sending this back to Eclipse, do not need to do any further dose painting. So from here, the ecomp plan is complete, and in Eclipse version 15, you can automatically send this back to Eclipse by clicking Export. If you prefer to use field and field, then you can review your max number of segments, the min MU per segment, and then generate field and field. This will convert the ecomp plan into a field and field plan. The ecomp plan is similar to sliding window with many control points, whereas with field and field, we're going to limit the number of control points based on the max number of segments that you have assigned. Now that the field and field plan is complete, we can again review those segments. And here you can see as I scroll through the different segments that have been generated, we can see what has been decided for this plan. These segments are not from a library. These are generated for the specific patient. So from here, if we'd like to send this back to Eclipse, we can click Export. And this is going to send our field and field plan back to the Eclipse treatment planning system. EZFluence shows an estimated dose, and we've worked quite a bit on making that algorithm as close as possible to what you'll see in Eclipse, but the final dose calculation and evaluation is always done in the treatment planning system. We find that users especially like this because it makes the commissioning for EZFluence much simpler. Because we're using the algorithm assigned in the initial plan, it knows exactly which one to use. And then from there, it will calculate using all of your approved beam data in Eclipse. Now this window here, this is showing us the progress of calculating the dose in Eclipse. So this speed will be similar to how long it will take you to calculate a breast plan with this many of segments in Eclipse. Once this window is closed, then we have our fully calculated plan in Eclipse ready to be evaluated. In this example, we went over a simple breast case. This was a single energy. EZFluence also works for mixed energies, and you can decide which fields you'd like to modulate. If you'd like to modulate the high energy, the low energy, or all of the above, you have all of those options. EZFluence is now being used in hundreds of clinics throughout North America and some in Europe as well. And so we find that this is something that you can customize to your liking. There are many different features to allow EZFluence to generate plans that work for your clinic and your physicians. So once the calculation is done, it automatically closes and it brings you back to Eclipse. And you can see then the plan is already fully calculated, ready to be evaluated in the Eclipse window. We can see we have a beautiful homogeneous dose distribution. I can scroll through and review the different slices. We can also see that in this case, my PTV eval was brought over from Eclipse, or from EZFluence, I should say. And then from there, we're ready to go. So we can see all of the different segments that have been brought over. And so you no longer need to worry about manually creating these segments. EZFluence can do that for you. And then when you're ready, you can merge your subsegments just like you normally would. So let's look at a whole brain case. So here I can see my whole brain case where I already have my field set up. I already have my blocks set up as well. And then from there, I'm going to calculate the open dose and then run EZFluence. So we're seeing more and more clinics using field and field for these whole brain cases. And so this is a way to help automate that. So EZFluence is going to work in a similar way to what we saw in the previous cases, where it will automatically generate a PTV eval structure. And then from there, it's going to try and come up with a homogeneous dose distribution for the overlap between the fields. And so in this case, while my PTV eval will be created the same way as the breast one, 5 millimeters from the skin, 5 millimeters from the field edge, instead I'm going to use my own whole brain structure. So this is going through, and our default is always the ecomp plan. So it is going through and generating those different ecomp plans first. And then once we have an ecomp plan that we like best, then we can turn that into a field and field. All right, so here I can see I have my different plan options, but instead of using the PTV eval, I'm going to use my brain structure that I've contoured. So I'm setting that as my target, and so now I can see this on my DVH. And then if I want to look at different plan options, I can do that as well. So I have similar options from before, so that looks great. And then if I wanted to make any adjustments, I can do that too. So from there, I can scroll through, make sure I'm happy with this plan. And then once this looks good, then we can convert this again into a field and field. Maybe just to show you real quick what that fluence looks like. So if you prefer to use sliding window, you always have that option. And then otherwise, you'll review the max number of segments, the min MU per segment, and generate field and field. So in this case, I'm going to lock JAWS just to make sure that I don't have any shifts between the different segments. So this now is going through and converting the ecomp plan into our field and field segments. Now, even though my max number of segments was set to 5, it won't always create 5 or the max number. So it's only going to create the number of segments that's needed for this type of plan. All right, and so my field and field plan is complete. If we go over to our Beam's Eye view, we can review the different segments here. And then if we're happy with this, ready to go, we click Export Field and Field, and this will send it back to Eclipse automatically. All right, so that's a whole brain case. So next up, let's take a look at a case that is more than just parallel opposed. So here's an example where you can have any beam arrangement, but the initial steps are going to be very similar. So we set up our fields, you set up the blocks, and then calculate the open dose. So from there, again, we're going to run EZFluence. But now this time it's going to see that it's not just parallel opposed beams, and it will ask you which field you'd like to modulate. I recommend modulating the fields where you would typically use a wedge or create manual segments. So in this case, I'm just going to turn off field number 2 for an example. You can click apply. So you can always leave all fields on if you prefer. So from there, EZFluence is still going to create this PTV eval structure. This is based on all the overlap between the fields. And then from there, it's going to come up with a homogeneous dose distribution using different fluence for each of the fields. So ecomp, again, is still our default. So then that way we can review the plan that's generated by EZFluence. And then once we're happy with that, this can also be turned into field and field if you prefer. All right, so now I have my 3D plan here, and I can see a very nice homogeneous dose distribution. Um, Now in a case like this, you'll notice the window is a bit different just because now we have a weighting space. For parallel opposed, you're not able to change the weighting as much just because now we actually have a lot more control and more degrees of freedom with the different fields. So in a case like this, let's say I am most concerned about the spinal cord. So if I turn that on my DVH, I can see what exactly it's receiving for this type of plan. And I'm going to turn on my absolute dose, and I can see that the max dose is just below the 40 gray mark. So if I wanted to bring this down, I'm going to locate the field that is contributing the most dose to the cord, and if I bring this weighting down, you'll see the other fields start to have more significant weight. But then you'll also notice that spinal cord dose is decreasing on the fly. So we can see that drop below now the 33 gray. So even though I have a low spinal cord dose, notice that my distribution now is not as homogeneous. So if I want to fix this, all I have to do is click apply, and this will go through and redistribute the coverage while maintaining that lower spinal cord dose. So it's going to acknowledge the weighting that we assigned to that field to bring that dose down, and then redistribute by editing the fluence values. So now we can see we have a more homogeneous plan yet again, while maintaining that lower cord dose. So from here, we can review the different fields. Again, this is the ecomp plan. Um, Field 2 we skip, that's just an open beam, and then 3 and 4 also have some fluence intensity values. If we wanted to turn this into field and field, we can do that too, and you just click generate field and field. So we're going to skip over now to another scenario with EZFluence. We can create all these 3D cases, and then some clinics are finding that something that can be time consuming is generating a 3D case for an IMRT plan for insurance justification purposes. So if you have your IMRT plan, whether it's VMAT or if it's static IMRT, then you can load that up in Eclipse and run EZFluence directly on the IMRT plan. So when you do that, the whole point of this is that we can then quickly generate a 3D case for you without you having to worry about generating the 3D plan. You already put in all the work for the IMRT case. We can handle the 3D. So from here, since this was an arc, you have the option to turn this arc into a certain number of fields. Let's say I want this to be in 5 fields. We can do that. It will automatically add in the fields. And then in addition, it's also automatically going to set your JAWS and also the MLCs. So you can see here we have some default options. If I wanted to adjust this margin, let's say I wanted to make this a 1 cm margin, I can apply that and it will automatically apply that to all of the fields. So this is one of my favorite features because you don't have to worry about fitting each individual field. It automatically sets them. If you find you wanted to use a different beam arrangement, we also have some presets here. So you can choose any of these beam arrangements. And so that way you can go through and decide which one is best for this type of plan. And again, the MLCs will automatically update anytime you make any changes to your fields. So then once you're happy with the beam arrangement and you're good with the margin for your target, then from there, this will create the 3D plan in Eclipse. It will calculate the open dose automatically for you. And then once that's fully calculated, then EZFluence will run on that 3D plan and we'll see the same prompt that we saw from the previous one, where it will ask us, which fields would you like to modulate? So this is a nice tool, especially just for clinics that find that they need to do a lot of insurance company justifications for IMRT cases. And even if they just come up once in a while, this can be a nice time saver. So here we can see that same prompt saying, which fields would you like to modulate? We can even follow the same workflow as before. We'll just modulate 1, 3, and 4. And then once we click apply, it will go through and then again, come up with these different plan options for us that will be ready for us to review. All right, and so here we have our 3D plan. You'll notice that the PTV eval is still being contoured. If you prefer to use your own in-house structure, you can always choose that from the list below, and then the DVH will automatically update. So that's the overview of EZFluence. You can see it's something that works on any 3D case. We see this as something that can help make your 3D planning more streamlined and hopefully save you some time. Thank you so much.